A safety lamp is any of several types of lamp that provides illumination in coal mines and is designed to operate in air that may contain coal dust or gases, both of which are potentially flammable or explosive. Until the development of effective electric lamps in the early 1900s, miners used flame lamps to provide illumination. Open flame lamps could ignite flammable gases which collected in mines, causing explosions, and so safety lamps were developed to enclose the flame and prevent it from igniting the surrounding atmosphere. Flame safety lamps have been replaced in mining with sealed explosion-proof electric lights. Background. Damps or gases. Miners have traditionally referred to the various gases encountered during mining as damps. Damps are variable mixtures and are historic terms. Fire damp, naturally occurring flammable mixtures, principally methane. Black damp or choke damp, nitrogen and carbon dioxide with no oxygen. Formed by complete combustion of fire damp or occurring naturally. Coal in contact with air will oxidize slowly and, if unused workings are not ventilated, pockets of black damp may develop. Also referred to as azotic air in some 19th century papers. White damp, formed by the incomplete combustion of coal, or fire damp. The mixture may contain significant amounts of carbon monoxide, which is toxic and potentially explosive. Stink damp, naturally occurring hydrogen sulfide and other gases. The hydrogen sulfide is highly toxic, but easily detected by smell. The other gases with it may be fire damp or black damp. After damp, the gas from an explosion of fire damp or coal dust. Contains varying proportions of black damp and white damp and is therefore suffocating, toxic, or explosive, or any combination of these. After damp may also contain stink damp. After damp may be a bigger killer following an explosion than the explosion itself. Open flame illumination. Before the invention of safety lamps, miners used candles with open flames. This gave rise to frequent explosions. For example, at one colliery in the northeast of England, 10 miners were killed in 1806, 12 in 1809. In 1812, 90 men and boys were suffocated or burnt to death in the felling pit near Gateshead, and 22 in the following year. Wood 1853 describes the testing of a mine for fire damp. A candle is prepared by being trimmed and excess fat removed. It is held at arm's length at floor level in one hand, the other hand shielding out all except the tip of the flame. As the candle is raised, the tip is observed, and if unchanged, the atmosphere is safe. If however the tip turns bluish-gray, increasing in height to a thin extended point becoming a deeper blue, then fire damp is present. Upon detecting fire damp, the candle is lowered and arrangements made for the ventilating of the area or the deliberate firing of the fire damp after the end of a shift. A man, known as a fireman, penitent or monk, edged forward with a candle on the end of a stick. He kept his head down to allow the explosion to pass over him, but as soon as the explosion had occurred stood upright as much as possible to avoid the after damp. As can be imagined, this procedure did not always preserve the life of the man so employed. When they came into regular use, barometers were used to tell if atmospheric pressure was low, which could lead to more fire damp seeping out of the coal seams into the mine galleries. Even after the introduction of safety lamps, this was still essential information. See Trimmed and Grange for details of an accident where pressure was involved. The lack of good lighting was a major cause of the eye affliction nystagmus. Miners working in thin seams or when undercutting the coal had to lie on their side in cramped conditions. The pick was swung horizontally to a point beyond the top of their head. In order to see where they were aiming, the eyes needed to be straining in what would normally be the upwards and slightly to one side direction. This straining led first to temporary nystagmus and then to a permanent disability. Mild nystagmus would self-correct if a miner ceased to perform this work, but if left untreated would force a man to give up mining. The lower levels of light associated with safety lamps caused an increase in the incidence of nystagmus. First attempts at safe lamps. Both on the continent of Europe and in the UK, dried fish skins were used. From them a faint bioluminescence occurs. Another safe source of illumination in mines was bottles containing fireflies. Flint and steel mills introduced by Carlisle Spedding before 1750 had been tried with limited success. An example of a Spedding steel mill may be seen in Whitehaven Museum, the Spedding family having a long association as the agents for the Lowther family of Westmoreland and the Whitehaven collieries. They consisted of a steel disc, rotated at high speed by a crank mechanism. Pressing a flint against the disc produced a shower of sparks and dim illumination. These mills were troublesome to use and were often worked by a boy, whose only task was to provide light for a group of miners. Although at first it was assumed that the sparks had insufficient energy to ignite the fire damp, the explosion at Wallsend Colliery on June 9, 1785 disabused miners of this fallacy. Fortunately only one man was killed and the man using the mill survived to give evidence. The first Clanny lamp used a pair of bellows to pump air through water to a candle burning in a metal case with a glass window. Exhaust gases passed out through water. The lamp gave out only a weak light, though it was intrinsically safe provided it was kept upright. It was heavy and ungainly and required a man to pump it continuously. It was not a practical success and Clanny subsequently changed the basis of operation of later lamps in the light of the Davy and Stephenson lamps. Oil lamps. Principles of operation. Safety lamps have to address the following issues: provide adequate light, do not trigger explosions, warn of a dangerous atmosphere. Fire requires three elements to burn: fuel, oxidant and heat. The triangle of fire. Remove one element of this triangle and the burning will stop. A safety lamp has to ensure that the triangle of fire is maintained inside the lamp, but cannot pass to the outside. Fuel. This is the easiest part of the triangle to consider. There is fuel in the form of oil inside the lamp and fuel in the form of fire damp or coal dust outside. Oxidant. There is an oxidant in the form of air present outside the lamp. The design of the lamp must allow the oxidant to pass into the lamp or else the lamp will extinguish. Heat. Heat can be carried by the exhaust gases, through conduction and through burning of fire damp drawn into the lamp passing back down the inlet. Control of the transfer of heat is the key to manufacturing a successful safety lamp. In the Purdy lamp the inlet and exhausts are kept separate. Restrictions in the inlet ensure that only just enough air for combustion passes through the lamp. A tall chimney contains the spent gases above the flame. If the percentage of fire damp starts to rise, less oxygen is available in the air and combustion is diminished or extinguished. Early Purdy lamps had a simple pierced copper cap over the chimney to further restrict the flow and to ensure that the vital spent gas did not escape too quickly. Later designs use gauze for the same purpose and also as a barrier in itself. The inlet is through a number of fine tubes or through a gallery. In the case of the gallery system, air passes through a number of small holes into the gallery and through gauze to the lamp. The tubes both restrict the flow and ensure that any backflow is cooled. The flame front travels more slowly in narrow tubes and allows the tubes to effectively stop such a flow. In the Davy system, a gauze surrounds the flame and extends for a distance above, forming a cage. All except the very earliest Davy lamps have a double layer at the top of the cage. Rising hot gases are cooled by the gauze, the metal conducting the heat away and being itself cooled by the incoming air. There is no restriction on the air entering the lamp, and so if fire damp is entrained it will burn within the lamp itself. Indeed, the lamp burn brighter in dangerous atmospheres, thus acting as a warning to miners of rising fire damp levels. The Clanny configuration uses a short glass section around the flame with a gauze cylinder above it. Air is drawn in and descends just inside the glass, passing up through the flame in the center of the lamp. The outer casings of lamps have been made of brass or tin steel. If a lamp bangs against a hard piece of rock, a spark could be generated if iron or untinned steel were employed. History and development. Within months of Clanny's demonstration of his first lamp, two improved designs had been announced, one by George Stephenson, which later became the Purdy lamp, and the Davy lamp, invented by Sir Humphrey Davy. Subsequently, Clanny incorporated aspects of both lamps and produced the ancestor of all modern oil safety lamps. George Stephenson came from a mining family and by 1804 had secured the post of brackersman at Killingworth Colliery. He was present at both the 1806 and 1809 explosions in the pit. By 1810, He was engineman and responsible for machinery both above and below ground. The pit was a gassy pit and Stephenson took the lead in work to extinguish a fire in 1814. For some years prior to 1815 he had been experimenting on the blowers or fissures from which gas erupted. He reasoned that a lamp in a chimney could create a sufficient updraft that fire damp would not penetrate down the chimney. Further observations of the speed of flame fronts in fissures and passageways led him to design a lamp with fine tubes admitting the air. Sir Humphrey Davy was asked to consider the problems of a safety lamp following the Felling explosion. Previous experimenters had used coal gas incorrectly, believing it to be the same as fire damp. Davy however performed his experiments with samples of fire damp collected from pits. As an experimental chemist, he was familiar with flames not passing through gauze. His experiments enabled him to determine the correct size and fineness for a miner's lamp. Davy was awarded the Rumford Medal and a £1,000 by the Royal Society in 1816 and a £2,000 prize by the country's colliery owners, who also awarded 100 guineas to Stephenson. However, the Newcastle Committee also awarded Stephenson a £1,000 prize collected by subscription. Dr. Clanny was awarded a medal by the Royal Society of Arts in 1816. Both the Davy and Stephenson lamps were fragile. The gauze in the Davy lamp rusted in the damp air of a coal pit and became unsafe, while the glass in the Stephenson lamp was easily broken, and allowed the flame to ignite fire damp in the mine. Later Stephenson designs also incorporated a gauze screen as a protection against glass breakage. Developments, including the Grey, Museler and Marsuit lamps, tried to overcome these problems by using multiple gauze cylinders, but glass remained a problem until toughened glass became available. Were the flame to go out in a lamp, then there was a temptation for the collier to relight it. Some opened the lamps to light tobacco pipes underground. Both of these practices were strictly forbidden. They clearly negated the whole point of the safety lamp. The miner was expected to return to the shaft to perform relighting, a round trip of up to a few miles. For men on piecework, this meant a loss of income and so was unpopular. From the mid-century onwards, and particularly after the 1872 Act, lamps had to have a lock mechanism which prevented the miner opening the lamp. Two schemes existed. Either a special tool was required which kept at the pit head or else opening the lamp extinguished the flame. The latter mechanism can be seen in the Museler, Landor and Yates lamps below. Such a lamp was known as a protector lamp, a term picked up and used as a company name. Only on the return to the bank could the lamp man open the lamp for refilling and service. Various different locking mechanisms were developed. Miners tend to be ingenious in finding ways of circumventing them. A number of additional lamps were supposed to accompany each gang of men, but restricting the number was an obvious economy for the pit owners. The light given out by these lamps was poor. Indeed, in early lamps worse than candles. The problem not solved until the introduction of electric lighting around 1900 and the introduction of battery-powered helmet lamps in 1930. The poor light provided yet another reason for miners to try to circumvent the locks. Early lamps had the gauze exposed to air currents. It was quickly discovered that an air current could cause the flame to pass through the gauze. The flame playing directly on the gauze heats it faster than the heat can be conducted away, eventually igniting the gas outside the lamp. The following table is compiled from Hunt 1879, article, Safety Lamps, following accidents such as Wallsend, Trimdon Grange and the Bedford Colliery disaster, lamps had to be shielded against such currents. In the case of the Davy, a tin can Davy was developed which had a metal cylinder with perforations at the bottom and a glass window for the light from the gauze. Clanny-derived lamps had a metal shield in the shape of a truncated cone, called a bonnet covering the gauze above the glass cylinder. The important principle is that no direct current of air can impinge on the gauze. The shield had the disadvantage of not allowing the collier or the deputy to check that the gauze was in place and clean. Lamps were therefore made so that they could be inspected and then the bonnet placed on and locked. Timeline of development 1760, Spedding patents his steel mill. June 9, 1785, Wallsend colliery explosion. Caused by a Spedding mill. May 25, 1812, Felling Pit disaster claimed 92 lives. This was the final stimulus to both Stephenson and Davy to start their researches. October 10, 1812, serious explosion at Mill Pit in Harrington near Sunderland. May 20, 1813, William Allen announces William Reed Clanny's lamp to the Royal Society of Arts in London. The original lamp was subsequently refined and reduced in weight to 34 ounces. October 1, 1813, institution of the Society for Preventing Accidents in Coal Mines, later known as the Sunderland Society. 1815, Clanny lamp tried out at Mill Pit, Harrington and found to be impractical. October 21, 1815, oil lamp delivered to George Stephenson for safety lamp trials. November 3, 1815, Sir Humphrey Davy announces his lamp to a meeting of the Royal Society in Newcastle upon Tyne, England. November 4, 1815, Stephenson tests improved lamp at Killingworth Colliery. November 9, 1815, Davy presents the paper describing his lamp. November 30, 1815, further improved lamp tested by Stephenson. December 5, 1815, Stephenson lamp presented to the Philosophical and Literary Society of Newcastle. January 9, 1816, first trial of a Davy lamp at Hebburn Colliery. 1816, Davy awarded the Rumford Medal and a £1,000 by the Royal Society, a £2,000 Service of Plate Prize by the country's colliery owners. 1816, colliery owners also award 100 guineas to Stephenson. 1816, Clanny was awarded a medal by the Royal Society of Arts in 1816. 1816, Newcastle Committee opens a subscription to correct the perceived injustice of the Royal Society Awards. A £1,000 awarded to Stephenson. 1818, Davy lamps reported to be in use in Flanders. August 5, 1818, Wallsend Colliery explosion, 4 killed. Caused by a Davy lamp. 1840, Matthew Louis Museler exhibited his lamp in Belgium. 1852, the South Shields Committee concludes that the Davy lamp is absolutely unsafe, the cause of some accidents. 1853, Nicholas Wood, President of the North of England Institute of Mining and Mechanical Engineers, presents the results of experiments on various lamps which concluded that the Davy was safe, but only had a small margin of danger. December 8, 1856, explosion at Nicholson's Pit, Rainton Colliery. One man died from his injuries 12 days after the explosion. Fire damp was ignited when being tested for with a Clanny lamp having a cracked glass. The inspector condemns the Clanny and recommends the Stephenson for light and the Davy for testing. 1859, William Clarke first patent for electrical lamp. 1872, Coal Mines Regulation Act required locked lamps under certain circumstances. 1881, Joseph Swan exhibited his first electric lamp. February 16, 1882, Trimdon Grange Colliery disaster, 69 men and boys killed. The coroner reporting to the House of Commons adjudged that, the result of this inquiry is a further proof, if further proof were needed, that the Davy lamp affords no security whatever, and that its employment ought to be absolutely prohibited. 1886, Royal Commission on Accidents in Mines tested lamps and made recommendations. 1887, Coal Mines Regulation Act made requirements on construction, examination and use. 1900, electric lighting in mines. 1911, Coal Mines Act made requirements on examination and use, including electric lamps. 1911, British government offers prize for best electrical lamp. 1924, Miners' Lamp Committee carried out tests and made recommendations. 1930, battery-powered helmet lamps. Examples of lamps Davy lamp. In the Davy lamp a standard oil lamp is surrounded by fine wire gauze, the top being closed by a double layer of gauze. If fire damp is drawn into the flame it will burn more brightly and if the proportions are correct may even detonate. The flame on reaching the gauze fails to pass through and so the mine atmosphere is not ignited. However, if the flame is allowed to play on the gauze for a significant period, then it will heat up, sometimes as far as red heat. At this point it is effective, but in a dangerous state. Any further increase in temperature to white heat will ignite the external atmosphere. A sudden draft will case a localized hot spot and the flame will pass through. At a draft of between 4 and 6 feet per second the lamp becomes unsafe. At Wallsend in 1818 lamps were burning red hot. A boy was employed to carry hot lamps to the fresh air and bring cool lamps back. For some reason he stumbled or moved the lamp too quickly and triggered the explosion. At Trimdon Grange a roof fall caused a sudden blast of air and the flame passed through the gauze with fatal results. Poor copies and ill-advised improvements were known, but changing dimensions either reduced the illumination or the safety. The poor light compared to either the Geordie or Clanny eventually led to the Davy being regarded as not a lamp but a scientific instrument for detecting the presence of fire damp. Some pits continued to use candles for illumination, relying on the Davy to warn men when to extinguish them. Stephenson Lamp. In the earlier Geordie lamps an oil lamp is surrounded by glass. The top of the glass has a perforated copper cap with a gauze screen above that. The glass is surrounded by a perforated metal tube to protect it. Later versions had an annular chamber around the base of the lamp into which air entered through small holes and from which air passed through gauze into the lamp. The glass was surrounded by gauze so that in the event of a glass breakage the Geordie became a Davy. In a strong enough current of air enough air could be forced in through the tubes to sustain the flame and the lamp could get red hot. The lamp becomes unsafe in a current of from 8 to 12 feet per second, about twice that of the Davy. Purdy Lamp. A development of the Geordie lamp was the Purdy. A galley with gauze provided the inlet, above the glass was a chimney with perforated copper cap and gauze outer. A brass tube protected the upper works, shielded them and kept them locked in position. A sprung pin locked the whole together. The pin could only be released by applying a vacuum to a captive hollow screw. Not something that a nicotine-starved miner could do at the coal face. Improved Clanny Lamp. Clanny abandoned his pumps and candles and developed a safety lamp which combined features of both the Davy and Geordie. The oil lamp was surrounded by a glass chimney with no ventilation from below. Above the chimney is a gauze cylinder with a double top. Air enters from the side and spent gases exit from the top. In the presence of fire damp the flame intensifies. The flame must be kept fairly high in normal use. A small flame permits the enclosed space to fill with fire-damp air mixture and a subsequent detonation may pass through the gauze. A larger flame will keep the upper part full of burnt gas. The Clanny gives more light than the Davy and can be carried more easily in a draft. Lupton notes however it is superior in no other respect, particularly as a test instrument. The glass on a Clanny was secured by a large diameter brass ring which could be hard to tighten securely. If a splinter occurred at the end of a crack, or indeed any other unevenness, then the seal might be compromised. Such an incident occurred at Nicholson Pit in 1856 on a lamp being used by an overman to test for fire damp. The mines inspector recommended that only Stephenson lamps were used for illumination and Davies for testing. In particular overmen, whose lamps are mostly used to detect the presence gas, should avoid such Clanny lamps. Museler Lamp. The lamp is a modified Clanny designed by the Belgian Mathieu Louis Museler. The flame is surrounded by a glass tube surmounted by a gauze-capped cylinder. Air enters from the side above the glass and flows down to the flame before rising to exit at the top of the lamp. So far this is just a Clanny, but in the Museler a metal chimney supported on an internal gauze shelf conducts the combustion products to the top of the lamp. Some Museler lamps were fitted with a mechanism which locked the base of the lamp. Turning down the wick eventually released the base, but by then the flame was extinguished and therefore safe. The lamp was patented in 1840 and in 1864 the Belgian government made this type of lamp compulsory. In the presence of fire damp the explosive mixture is drawn through two gauzes, burnt and then within the chimney only burnt gases, not explosive mixture. Like a Clanny, and the Davy before it, it acts as an indicator of fire damp, burning more brightly in its presence. Later models had graduated shields by which the deputy could determine the concentration of fire damp from the heightening of the flame. whilst the Clanny will continue to burn if laid on its side, potentially cracking the glass. The Musula will extinguish itself due to the stoppage of convection currents. The lamp is safe in currents up to 15 feet per second. Marsuit Lamp. The Marsuit Lamp is a Clanny with multiple gauzes. 2 or 3 gauzes are fitted inside each other, which improves the safety in a draft. Multiple gauzes will however interfere with the flow of air. The Marsuit was one of the first lamps to be fitted with a shield. In the illustration, the bonnet can be seen surrounding the gauzes. A shielded Marsuit lamp can resist a current of 30 feet per second. Bainbridge lamp. The Bainbridge is a development of the Stephenson. A tapered glass cylinder surrounds the flame, and above that the body is a brass tube. The top of the tube is closed by a horizontal gauze attached to the body of the lamp by small bars to conduct heat away. Air enters through a series of small holes drilled in the lower brass ring supporting the glass. Landau's lamp. The lamp is in part a development of the Geordie. Air enters into a ring near the base which is protected by gauze or perforated plate. The air passes down the side of the lamp, passing through a series of gauze-covered holes, and enters the base through yet another series of gauze-covered holes. Any attempt to unscrew the base causes the lever to extinguish the flame. The gauze-covered holes and passageways restrict the flow to that required for combustion, so if any part of the oxygen is replaced by fire damp, then the flame is extinguished for want of oxidant. The upper portion of the lamp uses a chimney like Musula and Morgan lamps. The rising gases pass up the chimney and through a gauze. At the top of the chimney, a dished reflector diverts the gases out sideways through a number of holes in the chimney. The gases then start to rise up the intermediate chimney before exiting through another gauze. Gas finally passes down between the outermost chimney and the intermediate chimney, exiting a little above the glass. The outer chimney is therefore effectively a shield. Yates lamp. The Yates lamp is a development of the Clanny. Air enters through the lower part of the gauze top and leaves through the upper part. There is no chimney. The lower glass part of the lamp has seen some development, however. It is replaced by a silvered reflector having a strong lens or bullseye in it to allow the light out. The result was a claimed 20-fold improvement in lighting over the Davy. Yates claimed the temptation to expose the flame to obtain more light is removed. The base also contained an interlocking mechanism to ensure that the wick was lowered and the lamp extinguished by any attempt to open it. The lamp was much more expensive than the forms of lamp now in general use, but Mr. Yates states that the saving of oil affected by its use will in 1 year pay the additional cost. Evan Thomas. The Evan Thomas lamp is similar to a shielded Clanny, but there is a brass cylinder outside the gauze above the glass. It resists drafts well, but the flame is dull. Morgan. The Morgan is a cross between the Musula and the Marsuit. It is a shielded lamp with a series of discs at the top to allow spent fumes out and a series of holes lower down the shield to allow air in. There is an inner and outer shield so that air cannot blow directly on the gauze but must first find its way through a slim chamber. There are multiple gauzes, like the Marsuit, and there is an internal chimney like the Musula. There is no shelf supporting the chimney, instead it hangs from an inverted cone of gauze. The Morgan will resist air up to 53 feet per second and is sufficiently safe for every practical purpose. Clifford. The Clifford also has a double shield, but with a plain flat top. The chimney is quite narrow with gauze covering the top. The bottom of the chimney has a glass bell covering the flame. The chimney is supported on a gauze shelf. Air enters through the lower part of the outer shield, through the passage and into the lamp through the inner shield. It is drawn down through the gauze, then passes the flame and descends the chimney. At the top it leaves through gauze and the top of the double shield. The inner chimney is made of copper coated with a fusible metal. If the lamp gets too hot, the metal melts and closes up the air holes, extinguishing the lamp. The lamp has been tested and according to Lupton successfully resisted every effort to explode it up to a velocity of more than 100 feet per second. Electric lamps. It was not until tungsten filaments replaced carbon that a portable electric light became a reality. An early pioneer was Joseph Swan, who exhibited his first lamp in Newcastle upon Tyne in 1881 and improved ones in subsequent years. The Royal Commission on Accidents in Mines set up in 1881 carried out extensive tests of all types of lamps, and the final report in 1886 noted that there had been good progress made in producing electric lamps giving a light superior to that of oil lamps, and expected economic and efficient lamps to become available soon. This turned out not to be the case, and progress was slow in attaining reliability and economy. The Sussman lamp was introduced into Britain in 1893, and following trials at Merton Colliery in Durham it became a widely used electric lamp, with 3,000 or so reported by the company in use in 1900. However, by 1910 there were only 55 electric lamps of all types in use, about 0.25% of all safety lamps. In 1911, an anonymous colliery owner, through the British government, offered a prize of £1,000 for the best lamp to specified requirements. There were 195 entries. It was won by a German engineer with the CEAG lamp, which was handheld and delivered twice the illumination of oil lamps, with a battery life of 16 hours. Awards were made to 8 other lamps that met the judges' criteria. Clearly this stimulated development, and over the next few years there was a marked increase in the use of electric lamps, especially the CEAG, Grey Sussman and Oldham, so by 1922 there were 294,593 in use in Britain. In 1913, Thomas Edison won the Raytheman Medal for inventing a lightweight storage battery that could be carried on the back, powering a parabolic reflector that could be mounted on the miner's helmet. After extensive testing, 70,000 robust designs were in use in the US by 1916. Early electric lamps in Britain were handheld as miners were used to this, and helmet lamps became common much later than in countries like the USA where helmet lamps had been the norm. Nowadays, safety lamps are mainly electric, and traditionally mounted on miners' helmets or the old-domed headlamp, sealed to prevent gas penetrating the casing and being ignited by electrical sparks. Although its use as a light source was superseded by electric lighting, the flame safety lamp has continued to be used in mines to detect methane and black damp, although many modern mines now also use sophisticated electronic gas detectors for this purpose. As a new light source, LED has many advantages for safety lamps, including longer illumination times and reduced energy requirements. Combined with new battery technologies, such as the lithium battery, it gives much better performance in safety lamp applications. It is replacing conventional safety lamps. The Office of Mine Safety and Health, a part of the National Institute for Occupational Safety and Health in the United States, has been investigating the benefits of LED headlamps. A problem in mining is that the average age is increasing, 43.3 years in 2013, and as a person ages vision degenerates. LED technology is physically robust compared to a filament light bulb, and has a longer life, 50,000 hours compared to 3,000. Extended life reduces light maintenance and failures. According to OMSHR, an average of 28 accidents per year occur in U.S. mines involving lighting. NIOSH has sponsored the development of cap lamp systems which they claim improve the ability of older subjects to detect moving hazards by 15% and trip hazards by 23.7%, and discomfort glare was reduced by 45%. Conventional lights are strongly focused in a beam. NIOSH LED lamps are designed to produce a wider, more diffuse beam which is claimed to improve the perception of objects by 79.5%. See also. References. Bibliography, A Looker On, Improper Lamps and Other Lights in Coal Mines, Tracts, Vol 214, pages 3-4, retrieved January 30, 2013. The real author may be Thomas Unthank. Brune, Jar 1/4 GENF, Extracting the Science, A Century of Mining Research, Society for Mining, Metallurgy and Exploration, Incorporated, ISBN 0873353226, retrieved February 7, 2013, Calvin, Ronnie, Cole, in Cameron, Alistair, Lakelands Mining Heritage, Cumbria Amenity Trust Mining History Society, ISBN 0-9539477-0x, Clanny, W.R., On the Means of Procuring a Steady Light in Coal Mines Without the Danger of Explosion, Philosophical Transactions of the Royal Society of London 103. 200 euro 205, doi, 10.1098/STL. 1813.0027, Clanny, William Reed, An Account of the Trial of Dr. Reed Clanny's Lamp in Some Newcastle Coal Mines, Annals of Philosophy, Vol. 7, 368 euro 373, Clanny, William Reed, Practical Observations on Safety Lamps for Coal Mines, Annals of Philosophy, Vol. 8, 353 euro 357, Clark, Neil R., Mine Safety Lamp Collection on display at the National Mine Health and Safety Academy, Holmes Safety Association Bulletin, retrieved January 10, 2013. Publisher's note, portions of the article came from E. Thomas and Williams. Davis, Hunter, George Stephenson, The History Press, ISBN 978-0-7509-3795-5, Dron, R.W., Mining Association of Great Britain, ed., Lighting of Mines, Historical Review of Coal Mining, 150 euro 169, Durham Mining Museum, Mill Pit, Harrington, retrieved January 10, 2013, Durham Mining Museum, Wallsend Colliery, retrieved January 16, 2013, Durham Mining Museum, In Memoriam, Robert Johnson, retrieved May 5, 2014, E. Thomas and Williams Limited, Original Types of Miners' Flame Safety Lamps, welshminerslamps.com, retrieved January 10, 2013. Fordyce, William, A History of Coal, Coke and Coalfields and the Manufacture of Iron in the North of England, Graham, Forster, G., Safety Lamps and the Detection of Fire Damp in Mines, London, George Routledge, Geopedia Fr., Mining Lamp Catalogue, Geopedia Fr., retrieved January 11, 2013, Gresco, Dave, Brief History of the Miner's Flame Safety Lamp, minerslamps.net, retrieved January 10, 2013, Hoffman, Frederick L., Miners Nystagmus, Washington, USA, Department of the Interior, Bureau of Mines, retrieved January 28, 2013, Home Office, Mines and Quarries, General Report and Statistics for 1900. Part 2 Labour, CD 766, London, HMSO, Hunt, Robert, ed., Dr. Year's Dictionary of Arts, Manufactures, and Mines, 4, London, Longmans, Green and Company. Johnson, Frank, A Brief Survey of the Development and Manufacture of Miners' Safety Lamps, The Protector Lamp and Lighting Company Limited, retrieved December 1, 2014, Jones, A.V. Tarkenter, R.P., Electrical Technology in Mining, The Dawn of a New Age, London, Peter Peregrinus, Knight, David, 8, The Safety Lamp, Humphrey Davy, Science and Power, Cambridge University Press, ISBN 0-631-16816-8, Lupton, Arnold, Mining, An Elementary Treatise on the Getting of Minerals, Chapter 11, retrieved October 19, 2014, Metcalf, Peter. Metcalf, Roger, Engineering Studies, Year 11, NSW Engineering Studies, NEM, List of descriptions of safety lamps held by the institution, New Wisdom Investment Limited, History Mineral Lamp, retrieved February 7, 2013, New Wisdom Investment Limited, LED Light Unit Li-ion Battery Miner's Lamp, retrieved February 7, 2013, Office of Mine Safety and Health, Mining Feature, NIOSH Illumination Research addresses visual performance needs with LED technology, retrieved October 12, 2014, Royal Commission on Accidents in Mines, Final Report Command Paper 4699, Smiles, Samuel, Lives of the Engineers, Volume 3, London, John Murray, ISBN 0-7153-4281-9, Snag, T.W., Report on the explosion which occurred at the Trimden Grange Colliery on 16 February 1882, retrieved January 11, 2013, Swan, J.W., Swan's Electric Light, Transactions, North of England Institute of Mining and Mechanical Engineers, Vol. 30, 149 euro 159, retrieved November 16, 2013, Thompson, Thomas, ed., Annals of Philosophy 4, Robert Baldwin, retrieved December 16, 2014, Thompson, Thomas, ed., Annals of Philosophy X, Robert Baldwin, retrieved February 27, 2015, Thompson, Thomas. Employment of Sir H. Davies Safety Lamps in Flanders, Annals of Philosophy, Volume 11, pages 394, retrieved April 22, 2015, Tanco Corporation, Solid Brass Miners Lamps, page, Full-Size Miners Lamps, retrieved March 12, 2013, Whittaker, J.W., Mine Lighting, London, Methuen, Wood, Nicholas, on Safety Lamps for Lighting Coal Mines, Transactions, North of England Institute of Mining and Mechanical Engineers, Vol I, 301 Euro 322, retrieved November 17, 2013, Wood, W.O., The Sussman Electric Miner's Lamp, Transactions of the Institution of Mining Engineers, XX Euro 1900 Euro 1901, 189 Euro 197 Euro via Internet Archive. Further reading, North of England Institute of Mining and Mechanical Engineers, Nicholas Wood Memorial Library Miners Safety Lamps, A Guide to Resources. 2014. A Guide to Books, Journals, Government Reports, Archival Material and Other Resources on Lamps in the Institute Library. Barry, D. The Wand of Science, A History of the British Flame Safety Lamp. Birmingham, D. Barry Risk Management Limited, 2006. Barnyard, T.R. Miners Safety Lamps, Their Construction and Care. London, Pitman, 1936. Galloway, R.L. Annals of Coal Mining in the Coal Trade. First Series. To 1835, London, Colliery Guardian, 1898. 420-439. Second Series. 1835-80, London, Colliery Guardian, 1904, 304-324. Hardwick, F. W. and O'Shea, L.T. Notes on the History of the Safety Lamp Transactions, Institution of Mining Engineers 51 1915-6, 548-724. History from 1813 to 1913 with many types of lamps described and testing discussed for the UK and other European countries. James, F.A.J.L. How big is a hole? The problems of the practical application of science in the invention of the Mincer Euro unregistered trademark safety lamp by Humphrey Davy and George Stephenson in late Regency England. Transactions, Newcomen Society 75, 2, 2005, 175 Euro 227, Kerr, G.L. Practical Coal Mining 5th ed. London, Griffin, 1914. C.H. Siv, Poths, H.A. The Miner's Flame Light Book, The Story of Man's Development of Underground Light. Denver, 1995. This is a U.S. emphasis. Watson, W.F. The Invention of the Miner's Safety Lamp, A Reappraisal Transactions, Newcomen Society 70, 1, 1998-9, 135-141 Euro. Oeto settle the disputed features of the lamps of Clanny, Davy and Stephenson Euro. External links and abbreviations, DMM, Durham Mining Museum, Miners Lamp Collectors Society, NEM, the North of England Institute of Mining and Mechanical Engineers, Wand of Science. The website resource for miners' safety lamp collectors. If I don't know Euro unregistered trademark T know it, I probably know a man who does.